batteries packed with energy, rare earth metals, and cutting-edge motors. These are the components that make EVs powerful. But mind you, because they're also what makes them extremely expensive and impossible to scale on low levels. The idea of a sub-$11,000 electric car was the stuff of fantasy for years. But now, under Elon Musk's relentless vision, it looks like Tesla has cracked this code. This is the inside story of how Tesla took on the battery cost crisis and built the car no one thought was possible. Elon Musk's impossible $11,000 gamble. By 2023, the global electric vehicle industry had matured, but not fully democratized. Supply chains for batteries remained heavily reliant on materials sourced from narrow and geopolitically sensitive corridors. China controlled more than half of global lithium refining and dominated graphite production. Cobalt extraction was deeply tied to politically unstable regions in Africa. South American nations held massive lithium reserves, but lacked sufficient processing infrastructure. The dream of a global EV revolution was at the mercy of a few tightly gripped bottlenecks. But one man, Elon Musk, saw the problem not just as logistical, but existential. If Tesla's mission was to accelerate the world's transition to sustainable energy, then dependency on fragile and ethically questionable supply lines was a direct contradiction to that mission. The only way forward was to go inward, to localize, simplify, and reinvent. This is where the Model 2 begins. Not in a sketchbook or design studio, but in the strategic war rooms where Tesla decided it had to build something that hadn't been built before. The $11,000 price point wasn't a gimmick, but a declaration of independence. Independence from supply chain fragility, from legacy auto-thinking, and from the idea that advanced technology must remain exclusive. From Earth to EV, how Tesla rewired the supply chain. The first problem in building the Model 2 with a shocking battery was sorting out the supply chain. As EV demand skyrocketed and global logistics cracked under pressure, Tesla realized it needed something more radical: total control over its entire ecosystem. From the raw materials under the earth to the finished car delivered to your driveway. Apart from the cost, it was also about agility, sovereignty, and resilience. In 2025, while most automakers still depend on battery cells and components shipped from across the globe, Tesla has completed a staggering industrial pivot, a fully localized, vertically integrated supply chain based in the U.S. In Corpus Christi, Texas, Tesla began refining lithium on American soil, a move previously considered too ambitious or unprofitable. Just a few hundred miles away, new facilities handle cathode and anode production with cutting-edge efficiency. These materials are then fed directly into Tesla's own battery cell assembly plants, eliminating the need for third-party manufacturers or overseas freight. Although the cost-saving benefits of this integration are significant, these are not the only benefits of this extraordinary move. It also means tighter quality control, accelerated R&D cycles, and freedom from trade disputes or shipping delays. While other automakers grapple with price fluctuations or raw material shortages, Tesla's supply chain is engineered for consistency and scale, and the payoff is tangible. The Model 2, slated to roll out by the millions, is being built in a way that bypasses nearly every traditional manufacturing constraint. Tesla isn't just making its own batteries, but building its own future, one that's immune to the vulnerabilities that still plague much of the industry. Now, let's get to the more technical side of this affordable beast that explains how Tesla upgraded the battery to perfection. The silent revolution inside Tesla's new battery. At the heart of the Model 2 lies the Gen 2 4680 battery, a technological leap that reshapes everything we thought we knew about EV performance, reliability, and affordability. On paper, it's just a battery. In practice, it's the difference between a future of accessible electric mobility and one that remains locked behind price barriers. The original 4680 cell was already a breakthrough, but the Gen 2 iteration refines it across nearly every metric. The most immediate change lies in the internal structure. Tesla's signature tabless electrode design now operates with even less electrical resistance, meaning lower internal temperatures and more efficient energy transfer during both charge and discharge cycles. Heat, long the silent killer of battery life, is now far better managed without bulky cooling systems. But the real upgrade comes from the materials. The Gen 2 cell swaps traditional graphite-heavy anodes for a silicon-dominant formulation, boosting energy density by 35 to 50%. This means more power in the same space, and therefore longer range without expanding the battery size or weight. On the cathode side, Tesla has pushed forward with a high-nickel chemistry that completely eliminates cobalt, aligning with the company's ethical sourcing commitments while still delivering top-tier performance. Combined with a rugged thermal barrier system inspired by solid-state technology, the result is a cell that's safer, longer-lasting, and dramatically cheaper to produce at scale. The Gen 2 4680 is expected to last over 1.2 million miles, enough to render battery replacement a non-issue for most drivers. More importantly, it unlocks a range of over 300 miles and a charging speed that hits 0 to 80% in just 15 minutes. This isn't an incremental step forward, it's a foundational reset. But listening to all this, one must wonder, where did it all go down? What was the factory that made it possible? And that's exactly what we'll find out in the next chapter. Brookshshires Battery Forge, the plant that made the Model 2 possible. Just west of Houston, nestled in the industrial corridor of Brookshire, Texas, lies a facility that, until recently, received little attention outside the industry. But this mega factory, quietly constructed and rapidly scaled, is now one of the most consequential pieces in Tesla's global strategy and the engine behind the affordability of the Model 2. Spanning over 1 million square feet, the Brookshire facility isn't just big, it's optimized. It's where Tesla mass produces two of its most critical technologies: the grid-scale Megapack energy storage systems and the LFP battery cells that power the Model 2. This dual focus isn't a coincidence. It's part of a tightly integrated vision where vehicle electrification and energy infrastructure evolve side by side. LFP, lithium iron phosphate. Batteries are often considered the workhorses of the EV world. Slightly less energy-dense than their nickel-based counterparts, but cheaper, more stable, and capable of enduring thousands of charge cycles without significant degradation. For a vehicle like the Model 2, designed for mass adoption and low operating costs, LFP is the perfect match. But Brookshire's impact goes beyond chemistry. Its proximity to Gigafactory Texas reduces transportation time and cost. Its automation systems, refined through lessons learned in previous factories, allow for rapid scaling without compromising quality. And perhaps most critically, it operates as a profit center. Tesla's energy division, powered in part by Megapacks built in the same facility, brings in steady, high-margin revenue that helps subsidize vehicle production. In other words, the success of Tesla's energy business isn't separate from the success of the Model 2. It directly fuels it. How Tesla's energy business lowers your car bill. While the spotlight often falls on Tesla's vehicles, it's the company's energy business, quietly growing in the background, that may be the most strategic component of the Model 2's affordability. The idea that your car could, in part, be subsidized by grid-level battery installations might sound far-fetched, but that's exactly what Tesla's doing. Tesla's Megapack business has expanded aggressively over the past few years, with major deployments in Texas, Shanghai, and Cali, Australia. These massive modular energy storage units are designed to stabilize electric grids, store excess renewable energy, and sell electricity back to utilities during peak demand. But what makes them truly powerful isn't just their hardware, it's the intelligence behind them. AutoBidder, Tesla's proprietary energy trading software, automatically monitors and participates in energy markets, responding in real time to demand fluctuations. It decides when to store, when to sell, and how to maximize returns with no human intervention. And the results speak for themselves. Each Megapack installation can generate tens of millions in revenue over its lifetime, often delivering 25% or more in gross margin. That profit doesn't just benefit Tesla's energy division, it directly contributes to the cost structure of its vehicles. The same automation platforms, AI models, and battery chemistries used in Megapacks are repurposed within the Model 2's production ecosystem. Manufacturing robots, supply management systems, and even material sourcing pipelines are shared between the two arms of the company, creating a cross-functional infrastructure that drives down cost across the board. This synergy creates a business model that's almost circular. Energy sales fuel profits, profits reduce car prices, and lower car prices increase EV adoption, further fueling the demand for energy storage. It's a loop that very few companies, if any, are positioned to execute. The People's EV, a $10,000 Tesla that redefines value. With so many moving parts in place, localized supply chains, next-gen battery cells, scalable energy-backed manufacturing, the moment finally arrives where it all converges into a single product, the Tesla Model 2. But make no mistake, this is not a stripped-down, entry-level car. The Model 2 has been engineered to challenge assumptions at every level, not only in how it's built, but in what it offers. Priced at just over $10,000 after available incentives, the Model 2 represents the most accessible Tesla ever created. But its appeal isn't confined to price. With the Gen 2 4680 battery inside, it delivers a real-world range of over 300 miles, matching or exceeding many vehicles 3 times its cost. The battery is built to last 1.2 million miles, meaning that for most drivers the concept of battery replacement is no longer even part of the equation. Charging time is just as impressive. Thanks to reduced resistance and efficient heat management, the Model 2 can reach 80% charge in under 15 minutes, faster than most coffee stops. For urban and suburban drivers, this ease of charging transforms the daily commute into something frictionless and routine. Even the ownership model breaks from convention. Tesla now offers a subscription-based approach. For just $99 a month, users can access the Model 2 with insurance, charging, and maintenance bundled in. This isn't just innovative, it's transformational. It turns car ownership from a long-term debt obligation into a low-cost, on-demand service. And because of the simplified design and the longevity of the battery, the total cost of ownership plummets. Over 5 years, owners stand to save thousands compared to even the most efficient gas vehicles. The Model 2 doesn't merely make EVs accessible, it makes them smarter, cheaper, and far more sustainable in the long run. Tesla's original promise was to create compelling electric vehicles that would push the world away from fossil fuels. The Model 2 doesn't just fulfill that promise, it supercharges it, bringing millions into the EV ecosystem without the need for luxury pricing or compromise. A global shockwave, Tesla's strategic checkmate. The arrival of the Model 2 is not something out of the blue. It is the culmination of over a decade of calculated moves, each one building toward this moment where Tesla shifts from leading the EV market to entirely reshaping it. With a planned production volume of 1.5 million units annually by 2027, Tesla is no longer scaling linearly. It's scaling exponentially, and it's doing so from a position of unmatched strength. Between Gigafactory Texas and the Brookshire Megafactory, Tesla has created a manufacturing backbone that combines battery production, energy storage, and vehicle assembly into a synchronized engine of output. Legacy automakers, despite years of investment, still struggle to match Tesla's cost structure and production velocity. Many others are also bound to legacy supply chains, labor agreements, and internal combustion-era thinking. And while competitors like BYD and GM have made strong inroads in electrification, none have yet cracked the code of ultra-affordable, high-range EVs at scale without relying on imported parts or cutting corners. Another thing that makes the Model 2 particularly threatening to the rest of the auto world is that it eliminates excuses. It proves that an automaker can design, source, build, and deliver an EV with exceptional range, safety, and intelligence for under $11,000, without subsidies or gimmicks. That kind of proof doesn't just raise the bar, it resets it. All in all, the Model 2 is a clear declaration that the EV revolution is no longer a premium luxury, but a practical, scalable, and inevitable part of modern life. It reframes car ownership as a service, energy as an integrated revenue stream, and manufacturing as a strategic weapon. And all this was made possible by Elon Musk's relentless vision.